Good morning, students, and I welcome you all for the digital classroom of science. Dear students, we had already started with lesson number 4, current, electricity, and magnetism. Half of the lesson is over, and the remaining part of the lesson I am going to explain you today, and I hope that we will be able to complete the lesson today. So let's start with the lesson. Going to start with a new type of cell, that is nickel cadmium cell. Now, as the name indicates, that nickel and cadmium are used in these type of cells. These cells are generally used in the portable gadgets. That means we can carry the gadgets from one place to another, and they are very easy to carry. And the very important point of this nickel cadmium cell is that they are rechargeable. In the olden times, once the batteries or the cells were used up, they were to be thrown, discarded, and we had to purchase new cells. But now the rechargeable cells are available. Once it's over, once the charge is over, we can again charge it and use it again and again. So it lasts for a very longer period of time. Now these cells, they can deliver 1.2 volt potential difference, and as I said, they are rechargeable. They can be charged again and again. Then next we are going to study about the electric circuit. Now as you can see on the screen, there is an electric circuit. The first one is the cell holder in which the cells are placed. It can be in the remote, it can be in the transistor, it can be in anything, any electrical gadget where the battery or the cell is used. And in the second picture, you can see that it is a simple electric circuit where you can see three main things. One is battery, from where the electric current is given. Second one is switch, that is also called as key. And the third one is the light bulb. Okay, and we have to join all these three with the help of a wire. Now this whole arrangement is called as the electric circuit. Now when we switch on, that is when we press the key, the circuit becomes complete and the current starts flowing and the bulb immediately starts glowing, right? That means the electric circuit is complete. But as soon as we switch off or we remove the key, okay, we open the key, the circuit is broken and immediately the bulb stops glowing, right? That means only when the circuit is complete, the electric current flows. But as soon as the circuit is opened, the electric current stops flowing, right? So in an electric circuit, the three important things are the cell holder, an electric bulb, and a plug key, which is used to open or close the circuit, right? You can see it very well. So when the current flows through the circuit, the bulb lights up. And on the removal of the cell, the electric current flowing through the circuit stops and the bulb also stops glowing, right? So this whole connection with all these three electrical components is called as electric circuit. Okay, and it is shown by the two lines you can see on the battery where it is written. One is big, that indicates the positive terminal, and the other one is small, which indicates the negative terminal. Now this electric circuit is also used in our home supply. How? Now when you press the switch of the fan, right? As soon as you switch it on, the fan starts moving. Now when you are pressing the switch, you are pressing the key which you can see in the electric circuit, right? So when you are pressing the switch, the electric circuit is completed, and the electric current starts flowing and the fan starts moving. Now if you want to stop the fan moving, what you do? You switch off, right? You again bring the switch in the earlier position, right? So what happens? The key is removed, the circuit is broken, the circuit is open, and thus immediately the flow of electric current is stopped, due to which the fan also stops. Similarly, when we switch on the light, that is the tube light or bulb in our room, we just switch on, we press the switch. As we press the switch, the electric circuit gets completed and the bulb starts glowing, right? That means the electric current starts flowing. Whereas if we want to put off the bulb, switch off the bulb, we just press the switch in the opposite direction, because of which the key becomes open, the circuit is broken, and the electric current stops flowing, and thus the bulb or the tube light also stops glowing. So this is how an electric circuit works. Okay, these are the three important things. Now the next is connecting cells. Now what is connecting cells? You might have seen that in transistor or in some electrical gadgets, we have to use more than one cell or more than one battery, right? Now why the batteries are used in more number, right? Now in such cases, in the previous screen also you had seen, when I had shown you the electric circuit, in the upper picture you had seen that there are 4 cell cases, right, where the 4 cells are to be put. So similarly, here 4 batteries, as you can see, they are joined with each other, right? So these are the dry cells which we use. Why more than one cell is used? That is to obtain more amount of potential difference. Why we want more amount of potential difference? Because we can obtain higher current because of number of cells. So whenever we want a higher amount of current, we have to join or we have to connect more than 2 or 3 batteries in a line, and they are connected so that more potential difference is created and thus more amount of current can be obtained. Now this connection of cells, where more than one cells are connected to each other, this are called as battery of cells. So this arrangement is called as battery of cells. Now we will try to understand how these batteries are connected to each other. That is how the battery of cells are connected to each other. Now in the second picture on the screen, you can see where I had written electric resistance or the load. 2 batteries are connected to each other, and as we know that the upper cap-like structure, that is the positive end of the battery, and the lower flat side is the negative end of the battery. Now you can see that the positive end of the battery is on the upper side, and the negative end of the first battery is connected to the positive end of the second battery, right? Now we had already studied that the electric current, the flow of electric current is nothing but the flow of electrons. Flow of electrons are always from negative to positive electrode, but the electric current flows in the opposite direction, that is from the positive to the negative. So here what you can see on the screen, the positive terminal of one cell is connected to the negative terminal of the second cell, right? Now here the positive is connected to the negative. Now each cell has a potential difference of 1 volt. So the total potential difference of these two batteries will be 2 volt because they are joined one with another. So 1 plus 1, the total potential difference of two cells is equal to 2 volt. Now next we are going to study about the magnetic effects of electric current. That is, when an electric current passes through a wire, a magnetic field is produced around that wire. Now this we are going to see with the help of this experiment. When you will come to the school, we are definitely going to show you this experiment, that when electric current passes through a wire, a magnetic field is created around that wire. Now first of all, we have to arrange the apparatus as shown in the picture. We have to take the inner tray of a matchbox, and then we have to place a small magnetic needle inside the tray. If you remember, last year I had shown you the magnetic needle and the different types of magnet. So the same magnetic needle which is used to find out the direction is placed in this inner tray of the matchbox, and then we have to take a long connecting wire and we have to wind this electric wire around the tray, and inside the tray the magnetic needle is placed, and then we have to join the two ends of this coiled wire around the matchbox with the help of a bulb, a cell and a key, with the help of which we can close or open the circuit. Now we have to mark the position of the magnetic needle, okay, and then after that we have to start the current. So once we had arranged the apparatus, we have to bring a bar magnet near the inner tray of the matchbox, okay. We will find that the magnetic needle changes its direction, and then we have to start the electric current. So how we will start the electric current? For starting the electric current, the circuit is to be completed. So we will just complete the circuit with the help of the key, and the circuit, as soon as is completed, the electric current starts flowing, and as soon as the current starts flowing, we observe that the magnetic needle again changes its direction. Now how it has happened? It has happened because when the wire which is coiled around the matchbox in which the magnetic needle is placed, as soon as the electric current flows through the wire, a magnetic field is created around the wire, because of which the magnetic needle starts moving and changing its direction. But as soon as we break the circuit, that is, we remove the joint with the help of the key and the circuit breaks, right? The bulb also goes off and the movement of the magnetic needle also stops. So this experiment proves that the magnetic field is produced around the wire when an electric current passes through the wire, and this was observed by the scientist whose name was Hans Christian Ørsted, right? He was the first one to observe this, that when electric current is passed through the wire, a magnetic field is created around it, and we had seen that when the magnetic needle starts moving as soon as the current starts flowing, okay. Now next we are going to start with the electromagnet, right? Now we are going to make an electromagnet. We are going to study how an electromagnet can be made in the laboratory, right? Now for this we will need a big screw or a nail, right? Then a battery, a plug and the connecting wire. So these are the things which we require, and then we have to arrange the apparatus as shown in the picture, right? You can see the iron screw, you can see the iron pins we had kept aside with a plug key is there which can open and close the circuit, and the electric cell or the battery is there which provides the electric current. Now what we have to do, we have to arrange the apparatus first in the given way. So we have to keep these iron pins near the nail, right? Now what we have to do, we have to just plug on the key, that is we have to complete the circuit. As soon as the circuit is completed, the electric current starts flowing through the wire, because of which the nail becomes a magnet or an electromagnet. And how we will come to know? The pins which are placed near the nail, immediately they are attracted towards the nail. Now earlier also they were placed near the nail, but they were not attracted towards the nail. As soon as the electric current starts flowing in the wire which is coiled around the iron screw, the property of magnetism was observed in the nail, and because of this property of magnetism, these iron pins, they get attached to the nail. Now we will open the key, that is the circuit is broken. So as soon as the circuit is broken, what will happen? The electric current will stop flowing. Now as soon as the current stops flowing, the iron pins, they get detached from the nail immediately. Why this has happened? Because we had studied that when the electric current flows through the wire, right, it creates a magnetic field, and as soon as the current stops flowing, the magnetic field is vanished. So as soon as the electric current was stopped, the property of magnetism which was induced in the nail, that also vanished. Correct? So this also proves, this also shows that when an electric current flows through the electric wire, a magnetic field is produced around the wire. But as soon as the electric current is stopped, the property of magnetism or the production of the magnetic field is also stopped. The last we are going to study in this lesson is the electric bell. Very common thing. We all are having bell at our entrance door, right? So this electric bell also works on the principle of electromagnet. There is an electromagnet inside this electric bell, right? So let's first of all study about the structure of this electric bell. Now in the very first picture you can see this is exactly the electric bell, and the internal structure is shown in the second picture, right? You can see that there is a very big plate-like structure which is the bell. Then you can see the striker, like we beat the drum manually. Similarly, this striker beats on this bell and the bell rings. Then there is an iron strip which joins this striker with the contact screw. And then you can see the electromagnet, a battery where the plus and minus sign is shown, and the key. Key is the switch. When we press the switch at the doorbell, right, the bell strikes, right? Now we will study how this works. Now as you can see that there is a copper wire is wound around the iron piece, right? There are two such iron bars on which the electric wire is wound, and this whole thing works as an electromagnet. Then an iron strip along with a striker is fitted near the electromagnet, which I said, which joins the striker with the electromagnet. Now the current starts flowing in the circuit when the screw is in contact with the strip, right? Now when we press the switch, the current starts flowing. As soon as the current starts flowing, a magnetic field is created around the wire, and because of which this striker strikes the bell and it hits the gong and the sound is created. Now at the same time, the contact screw loses the contact with the strip and the current in the current stops. Now in this situation, in this condition, the electromagnet loses its magnetism, right? Because the circuit is incomplete and the electric current is not moving. So thus this iron strip, it moves back and the striker also moves back in the original position. Now as soon as we again press the bell switch, the current starts flowing. Again it becomes a magnet, and because of which the striker hits on the bell and the sound can be heard. This action goes on repeating itself and the bell rings. So the electric bell also works on the principle of the electromagnet, right? And what is an electromagnet? It is nothing. When an electric current flows around the wire, in a wire, it produces an electric magnetic field around it, because of which the property of magnetism is induced in the wire. Okay, but as soon as the current is stopped, the magnetism also is vanished. Okay students, with this we finish with the lesson, that is the so students, with this we finish with lesson number 4, current, electricity and magnetism. And in the next science lecture, first we will continue with the workbook exercise of this very lesson, that is lesson number 4, and after that we will complete the second lesson, which is still remaining only the workbook exercise. So please be prepared with the answer, find out the answers from the textbook, and in the next science lecture be ready with your workbook, your textbook and the answers. All the best. Take care, stay home, stay safe. Thank you.